So joining me now here in Mission Control Houston, Dr. Hans Christian Gunga. He's one of the principal investigators for the Circadian Rhythms study. It's taking place right now as we speak on board the International Space Station. Japanese astronaut Koichi Wakata is engaged in it. Dr. Gunga, thanks so much for being here today. Really appreciate it. And first, start me off real quick. What is this Circadian Rhythm study? Why are we doing it on board the International Space Station?
Actually, that is a very important question because the astronauts they do not have a real day there. They have several days and sunsets and such. So there is over the millions of years we have developed, the organism has adapted to this sunset and sundown. So we have an internal rhythm, and this internal rhythm is very important for your capabilities, for your vigilance, for all the things you are doing, whether you sleep or not sleep. And so if that rhythm is destroyed by having every day several times sunsets and sunrise, that makes it
sunset, sunrise, sunset, every 30 minutes or so.
That's actually the case, and that's why we introduced this study to analyze by measuring the core temperature. That means the temperature in the body. The temperature in the body is a signal for this circadian rhythm. You usually have in the morning here on the ground between 5 and 6 a.m. you have the lowest temperature. That means in the body about 36.5, and you have your highest temperature in the afternoon at 6 p.m. or so. And this is about 1 degree. It sounds less. It's only 1 degree difference.
It's not a huge difference, but it's measurable.
But it's measurable, and it's a strong signal for the organism. You must realize that the core temperature, this changing of metabolism and several other functions, they are introduced by your internal rhythm, which is coming from all the different, or it's organized from the different inputs. And the core temperature is, so to say, the master of the orchestra, of the different functions. It's like an orchestra. And you can expect if the master of an orchestra is not ready, and if it's working with different orchestras, that's a mess.
It can mess you up. Well, so, and like I had mentioned, Koichi's participating in this right now on board the station. What's he doing? See, you have the device right here.
Actually, it's the same. It's not exactly the same, but it's the same measurement device. And here you see, this is a kind of sensor we are using for the measuring of the core temperature. And usually you have to go with several probes into the rectum, into the ear, and that's not feasible for them.
A little uncomfortable for
that's very at least it is uncomfortable. But this is a new type of sensor. It's actually not measuring the temperature, but it is measuring the heat flux from. For example, he's placing that on your front, and there's it fixed for 36 hours. And here inside you have two sensors, and one sensor is measuring the heat coming from your front, going to the first sensor, and then going to a certain material, and then coming to the next sensor. And this heat flux represents in some way your body core temperature, especially on the
kind of an indirect way of measuring
that. It's an indirect way which is has to be transformed by certain algorithms to get the core temperature profile. That's what we need.
All right.
And that's later on. That is stored then on these devices, and we get the data down several weeks later. And we do this measurement not only on one time, but in the early beginning, and then every month at least, so that we can see whether there is a change in this curve of the core temperature. And we expect that the amplitude, so to say, how the delta between normally, that is reduced due to certain facts.
Okay. Well, so what are you guys really hoping to find out and almost solve? So
that's one of the main points we would like to look at. When in the mission we have certain rhythms, and whether you have the same rhythm as I have. So it's not clear who is more disturbed by this kind of circadian rhythm changes and the others. So this gives you an example and gives you some hints about the capabilities of the different subjects, and at least it's important, for our opinion, for really long-term space flights. And we have to look at methods and at technologies probably to keep that rhythm, and that can be done by special lights or by very structured meals or so, very structured day. Then you can have some inputs, and we are working on that. But that is so to say the terrestrial part. There's also the space part. We have also a terrestrial, because this is now just in the last year we had several measurements in the German Heart Center for heart transplantation, because these people, they have not a high temperature, they get very low. They had a body temperature at 16 or 15 degrees, so they are very, very low they are waiting for the heart. And this device can be placed outside the thorax and to protocol their core temperature.
So very non-invasive.
Very non-invasive. It's easy to clean, and I think in future you will hear much more about heat flux sensors in clinics, for monitoring, for example, not only at big operations like heart transplant, but any kind of narcosis will shut down your possibilities to regulate your temperature. And so you probably after you get hypothermic, because your body do not react. And this can be protocoled by this temperature. And so there's a direct clinical application of this method, which we designed for space.
So, I mean, and that really is an amazing, Earth example of just technology developed to find out why astronauts can't sleep, and now it could do something. I mean, it's amazing how it can transfer.
We are very happy that this could be transferred to it, and looking forward about the results.
All right. Well, again, Dr. Hans Christian Gunga, one of the principal investigators for the Circadian Rhythms study. Thanks for coming on and telling us about it. It's fascinating. I mean, I hadn't even thought about temperature being used to regulate sleep cycles, things like that. I just learned something pretty amazing today. So I really appreciate you coming on.
Oh, thank you.
Thank you.